So what is an L3 out and why do we need an L3 out? So we're going to go ahead and take a look at a couple of things. So let's say we have our traditional ACI Fabric. And let's say I have the internet out here, right? So you're going to need to connect ACI to an upstream device. That's what's providing access to the outside. In my example, this access is going to be the internet, but this could well be a cloud segment. It could be your WAN. It could be some type of campus access, right? So basically, this device over here is what's going to take me to the outside world. Depending on how you're deploying ACI, that device can be multiple things. That device can actually be a router. That device can be a firewall. It really is going to depend on how you're migrating and how you're deploying ACI. We're going to touch on this specific topic once we get to the migration session. For the sake of this discussion, I don't care what that device is. What I just care about that device is that I need to connect that device to ACI, and that connectivity is going to be provided through layer 3. Okay. The way I can do this in ACI, ACI supports static routing. It supports EIGRP. It supports OSPF, and it supports BGP. Right. So those are the routing protocols that are supported. And if you don't want to do a routing protocol, you can do static routes within ACI. Okay. So let's take a look at how ACI is going to forward the traffic. Okay. Let's assume I have server A here, and I have server B here. And I'm trying to get to Google. Okay. So this is /24/24. And I'm going to say we have the same default gateway on both of the leaves, correct? So I just wanted to go through these two examples because the way ACI forwards the traffic on this leaf here, let's call this device 103, and let's call this device 102. The way ACI is going to forward the traffic on that leaf 103 and that leaf 102 is going to be different. Right? So we need to understand why that is different and how the traffic is going to be forwarded. Okay. So we'll start with leaf 103. Okay. So let's say that for this example, we set up OSPF, which is what I'm going to be showing you on the labs. That's what we have on the setup. So I'm going to be doing an OSPF peering between ACI and this router here. Let's call this router 1. So the peering is going to be done between leaf 103 and router 1. What that means is that if I connect to leaf 103 and I do a show IP route, I should have a routing entry that points to the 8.8.8.8, either because I'm learning that route, and in this case, because it's the internet, because I'm getting some sort of default route from that router 1 device. Okay. But the key thing here is the forwarding for this is going to be based on OSPF routing table. Right? We're going to walk through the config of setting out the L3 out, but basically you're going to be doing a very similar config that you would do on a Nexus device. We're going to set up the OSPF process. We're going to define the area ID. We're going to define what type of area it is. We're going to define the IP for the interface we're using to peer. And then we're going to need to advertise the routes we want to advertise out from ACI to the outside world. And obviously, we're going to be getting routes from that R1 device. Okay. the key thing here is this routing is done based on OSPF. So if you want to think of it, I'm carving a space here and I'm creating like a mini router inside of that leaf 103, and that router is pairing with the R1 router. Okay? So the question would be, how does leaf 102 know how to send traffic to the outside world? Okay, as we had discussed in the first session we had when we did fabric forwarding, when a leaf doesn't know how to send traffic, when the leaf doesn't have information on where to send the traffic was sent to the spines, right? That was kind of the lookup process. Then the spines had the coup tables, and the spines decided where to forward traffic. Okay? So what you might be inclined to think is, okay, if leaf 102 is obviously not a part of the OSPF process. Leaf 102 is not running OSPF, so obviously if I do a show IP route in leaf 102, I'm not going to be getting any routes, right? So is leaf 102 going to send the traffic to the spines? Am I going to rely on a coup for the forwarding? And that's not the case. What ACI does, and this is one of the first things you're going to be setting up when you bring up your ACI Fabric, you're going to be setting something that's called the BGP policy, right? That BGP policy is an implicit rule which basically does this. We set up these two spine devices as route reflectors, and all the leaves become route reflector clients. Okay. So that's the first thing. They're going to be the only thing you need to do to set up this BGP policy is define an AS number and define which are the spines, and those are going to be becoming the route reflectors. So what ACI does is anytime you establish anything on the L3 out, so if there's static routes, ERGP routes, OSPF, or BGP routes that are present on this leaf 103, those routes are injected into the BGP process that's running inside of the fabric. Okay? And these guys being injected, these guys will get the route. So in our example, if I'm getting a 0000/0 route from router 1, that 0000 is going to show us an OSPF route here. That if I do the verification on leaves 102 or leaves 101, this is going to be a BGP route that I'm getting for the 0000. Okay. Why is this important to understand? The reason this is important to understand is if you don't understand how this redistribution works, you might have some weird traffic flows, or not weird, but the traffic flow is going to be not what you expect. And this might be the reason that some of you could have heard the term using a border leaf or dedicating a border node just for L3 out connectivity, right? That's the node you want to use to connect to the outside. Okay. So we're going to get into that example now with a little bit of a more complex topology to understand why we have a requirement and why it's important to understand this difference between the OSPF process and the BGP process. Okay. Are there any questions so far? No questions? Good. Okay. So let me take this out for a minute. So let's say I have similar topology, but a little bit more complex. So I'm going to have 2 spines, and I'm going to have 4 leaves. Okay. So what I'm going to say is just 101, 102, 103, and 104. Okay. I'm going to say that now I have 2 border devices. Okay. And I'm going to call this ISP1, and I'm going to call this ISP2. Now I'm going to say I have server A here, server B, server C, server D. They can all be part of the same subnet. Okay. Let's say I'm doing OSPF here. So I'm going to have the OSPF process running here. I'm also going to have OSPF process running here, which means they are going to be running OSPF. They're going to be running OSPF. And then these 2 guys here are going to get those routes as BGP routes. Okay. So let's say that I want to do some traffic shaping, and I'm going to say that this is the preferred route. And so I'm going to tweak the metrics, and I'm going to define that this path is the preferred path. It's going to have a better OSPF metric. And then I'm going to say that this is the least preferred path. So I'm going to tweak the OSPF metric, and that's going to have a least preferred metric. Okay. So in the event we did this, what's going to happen is server A obviously is going to take this route. If you take a look at server C is going to go to leaf 103. 103 is going to do the BGP lookup process. They're going to see the BGP route, and the BGP route is going to be pointing to 101. So he's going to be sending the traffic there. So it's going to take the preferred way. 104 is going to follow the same logic. But 102 is going to have a weird behavior. But not weird, it's the expected behavior. It's not just what you want. Even though leaf 102 is going to get a BGP route pointing to 101 for that prefix, the BGP route is going to have an administrative distance of 200 because this is IBGP. So even though we want to take this route going out of the fabric because this is the preferred path, in our example and the way this is set up, what's going to happen is we're going to take the OSPF route, because even though he is getting this route, he's not going to install that route into the routing table because the OSPF has an administrative metric of 110, and this is going to be the preferred way. Okay. So it's just important to keep in mind that you might see these behaviors if you're connecting servers to the nodes that you're also using to connect to the outside world. In the event that you are not tweaking the routes and both these OSPF metrics were the same, what would happen is these guys would get the BGP routes, and the BGP routes would have the next hop, basically two, the next hop of 101 and the next hop of 102. So basically they would be equal cost multipathing, okay? So the next thing we need to discuss is the options I have to setting up the L3 out. And before we discuss these options, I'm going to show you in the GUI how the L3 out is set up and where it's found, so you understand some of the discussion and what the options are going to be. Okay, so give me just 1 second. So if you go to networking, you go to external routed networks, and from here you can create an L3 out. Okay. So you're going to give it a name. You're going to choose, if you're doing a dynamic routing protocol, you would set it up from here. If you want to do static routes, you would actually do it when you define the nodes. Okay. So I'm just going to set this as OSPF. You can give it the area ID. You can choose the area type. I'm going to bind this to a specific BRF. Then I need to choose the external routed domain. The external routed domain follows a similar logic as the external bridge domain or the physical domains. They are created on the Fabric tab. And they used to basically to define the physical interfaces you're going to be using for the L3 out. So you would follow the same process we discussed last week. The only difference, it's set up specifically for the L3 out, the same way it was done for the L2 out. So you would create them here, but the config that goes inside is exactly the same. Inside of the external routed domain, you would define a VLAN pool and an AEP, and then you would bind that to the policy group and so on. Okay. So we find, and then we're going to create the node profile. So for the node profile, basically here is where we're going to be defining the actual physical interface, and we can give it the IP. We can choose how we want to treat that physical interface. Basically, the interface can be created as an SBI. It can be created as a sub interface, or it can be created as a routed interface, right? Just a single interface. So all this test. Here you would have the nodes. And here you can choose the node. Right? I can define router ID, I can define specific loopback addresses if I wanted to. And this is where you would define static routes. So if you wanted to do static routes instead of a dynamic routing protocol, in the first page, you would not select any routing protocol. And then when you're creating the nodes, here you would create the next hop, the preference, and here you would define the prefix you're routing for. So we can create the node. And here is where you're going to have two choices on how you work with L3 outs. Right? Go back to the drawing. The way we work with the L3 outs and the two options you're going to have is you can create one L3 out and have that L3 out have two nodes. Or you can create two L3 outs, basically. L3 out 1 and L3 out 2. And then each one of the L3 outs would have one node. Node 1 and node 2. So what is the difference between doing this and doing this? In some cases, it's going to be exactly the same. And in some cases, it's going to make a huge difference on how you do it. Okay? So when does it make a difference? If I were to ask you, how can I advertise a route in traditional Nexus? Right? If I have Nexus running OSPF and I want to advertise a specific prefix, how do I do that in Nexus? Who wants to volunteer? Okay. So in Nexus, we have the traditional ways of advertising the route, which is I can do route distribution, something like distribute connected. We can create a route map. We can create a prefix list. We can use the network statement if we have that network defined in the router. That's the ways we would do it on traditional Nexus. You're going to see that in ACI, there is no place where you do a network statement. Right? In ACI, you have two ways of advertising the routes. One way, which was the first way introduced, was binding the bridge domain to an L3 out. Okay. What that means is if I take a look at my bridge domain, and I take a look at the options for the bridge domain, if you go to policy, L3 configurations, inside the L3 configurations, there's an option that says associated L3 outs. Okay. What associated L3 out means is that you're binding this bridge domain to this L3 out that is created, right? In my example here, I have this L3 out already created, and I'm binding the bridge domain to that L3 out. What that is doing is it's telling ACI that whatever subnets are defined inside of the bridge domain and have a scope of advertise externally, those routes are going to be advertised through the L3 out. That is one option. The second option is you can actually create a route map. And in the route map, you can define what you want to advertise. Right? So here I could define the prefix. I want to advertise the same way I would do with Nexus, right? The key point to remember here is if you do it as a route map or if you do it inside of the bridge domain, you are binding to an L3 out. You're mapping that to an L3 out. You don't have an option of defining which node inside of the L3 out, right? Which node inside of the L3 out I'm which node in the L3 out I'm going to be using to advertise. Okay, so if we go back to our example, and let's say I have a setup similar to this, where I'm using two different ISPs. If I wanted to say that this route is not preferred, so this is the preferred route. Or if I wanted to say that I want to advertise prefix 10.0.0.0 only on this L3 out, and I don't want to advertise it here. If you want to do that, that option is not going to be available if you do this. Because in order for you to tweak the metrics or in order for you to advertise routes, that definition is done inside of the L3 out. So if you have your environment set up this way, you're not going to be able to influence and say that this is going to be preferred over this. If you create the L3 out here as two separate L3 outs, and you say that node 1 or leaf 1 is one L3 out and leaf 2 is a different L3 out, here you're going to be able to make change the settings, basically set the metric, advertise routes out of one L3 out, but not the other one, right? This is going to give you more control. Obviously, if you're doing this, it's an extra bit of configuration because you need to do the work for the L3 out twice. The end result from an outside device is the same, right? So if this is leaf 101 and this is leaf 102, and I have them both connected to one router, for example, this device would see this as a neighbor, and it will see this as a neighbor as well, regardless of if you do one L3 out or two L3 outs. What the outside world is going to be seeing is the same because they're basically just going to be seeing an OSPF neighbor, right? So the difference of creating one L3 out with two nodes or two L3 outs with one node each is on the level of control you have if you need to make any changes on the routing. My suggestion is I would, most of the time, when possible, I try to use this logic. If I have two devices that are inside of the data center, which are kind of the border, but those devices are on the inside, and these are the ACI leaves. What I would do is say, I'm going to create one L3 out with two nodes. And then if I need to do any traffic shaping connecting these devices to the outside, I would do any shaping on these devices and just have one simple L3 out that has two nodes inside, because you need to do less config and you have more control on how you advertise the routes on these devices here. Whereas if I'm connecting, this is 101 and this is 102, and I'm connecting to ISP devices, or I'm connecting to devices that are either outside of the data center or not managed, I would create one L3 out here and one L3 out here. The reason I would do that is because even if right now you don't have any requirement to change the metrics or say that this is going to be preferred over this, that requirement might change down the line. And if that requirement changes and you don't have management of those devices, or those devices are outside of the data center, that could be a challenge for you. So if I'm going to have a setup like that, I would rather create 2 different L3 outs, even though it's a bit of extra work. Because if I need to make any changes, if I need to influence the metric, if I want to advertise something out of one node and not the other one, it's going to give me more control, right? It's going to give me more options. Again, this is not a set in stone best practice. It's more of a bit of my experience and also a bit of personal preference on how you want to do it. Okay. So if we keep going through the configuration I was showing, we have the node profile. I define to which node I'm applying. Here I could add the second node if I wanted to. And here I'm going to define the interface profile. This is where you would actually define not just the node, but the actual interface and the IP addresses you want to use, right? Test. Not going to be using any of these, so I don't need to go through it. Here's where I would define the interfaces. You can do router interfaces, you can do SVIs, or you can do sub interfaces. Right? For example, if you were to set up an SVI, here you define the port you're using, right? So the node, the interface, the VLAN, and I could define an IP address. For the MTU, I would define the MTU manually. Sometimes I've seen problems when you do the inherit. It doesn't take 1500, and you might get exchange start stuck with OSPF. So just put this here. But basically, we create that, and then we would be able to create one for the other side. Okay. Actually, this would be like /30s. Okay. So as you see, you can create 2. So this is, I'm going to cancel out because those interfaces are not actually set up. But that is how you set up the L3 outs. Okay. Any questions with what we've seen so far before we keep going? Nope. Okay. So what we're going to do now is I'm going to erase the L3 out that is already set up. I'll just make a quick note of the IPs that are being used in the lab. And we'll go ahead and recreate all of this from scratch, and we'll have a discussion on how the actual L3 out is set up. So give me a second. I'll just make a quick note of this. One, two. And we're using interface 1/45. Okay. So we're going to go ahead and we're going to erase the L3 out. And we are going to recreate from scratch. So we'll erase it here. And we'll go to the bridge domain. And we'll erase the associated L3 out. You're going to see that you have a fault on the bridge domain when you erase the L3 out because the object is not present anymore. So we'll go ahead and erase this here. And so we're ready to start from scratch. We're going to open up a CLI. Yes, David, do you have a question? David? You're muted now. Oh, yes. There you go.
I was just thinking, isn't there a requirement for a contract as well when you're doing the layer 3 out?
Yes, there is. So once I create the L3 out, we're gonna discuss the options inside of ACI calls it a network. It's actually that network that is called in the L3 out is what we call the external endpoint group. So once I create the L3 out, we'll talk about the contracts there and some of the options for that network. Okay. So I'm going to connect to one of the leaves. And we're going to make sure that OSPF process is not running. So we'll do a show BRF. So IP OSPF neighbor BRF group 1, which is the one we're going to be working on. So no neighbors. And then we'll check if 2 as well. We'll do the same thing, show IP, OSPF, neighbors. So we verified there's nothing running, so we're gonna go ahead and start the config, okay? So come to external routed networks, create router outside, OSPF, the out. We're going to be using OSPF. We're going to be using area ID 1. It's set up as a not so stubby area. The BRF we're going to be choosing is the group 1 BRF. Said we need to use external routed domain, so we're going to use the one that was created. And I'm going to start creating the nodes. So I'm going to call this OSPF nodes. I'm going to define node ID 1, router ID 1.1.1.1. And then I'm going to create node 2, router ID 1.1.1.2. Okay. So we're going to create the interfaces. Okay. So we're going to create OSPF interface using any of these options. We're going to be using SVIs. So we're going to have 2 SVIs. We had node 1, interface 1/45. Sorry. So 1/45. And we're using VLAN 61. 192, 168, 201.2/30. 100. Oh, I'm gonna add and click OK here. Sorry, we're going to add the second node. So we're going to be using node 2, path 81, 192.168.201.6/30 in this one. 81 is fine. 1500 here. Okay. So we're going to go ahead and create this. We'll click OK here. We'll click Next. And we're going to create the external EPG networks. In the actual GUI, you're going to see that it's just called network. It's not called external EPG networks in this release. But if you see network, it just means the external input group. Okay. So external EPG. And I'm going to create something very simple. So I'm going to create the 0 prefix because we're expecting traffic from the internet, so any type of traffic. And I'm just going to leave this option here. I'm not going to get into these options now. Let's finish the discussion on the setup and do the verifications on OSPF. And once that is running, we'll come back to this and explore what these options actually mean. Okay. So we're going to finish the config. And we can check and see if we have any faults. There were some faults, but they are resolved, so it's good. So now we're going to go and check again if the neighbors are coming up here. Okay. So we're seeing that now the neighbor is coming up. We're going to check leaf 1 now. Sorry. Okay. Okay, so we see that they're both coming up. So we're going to do the verifications to see if my environment is correctly set up. Okay. So if this is properly set up, I should be able to get to the 192.168.101.11 network. This 192.168.101.11 is an endpoint group I have connected inside of ACI. Is this web server here. So if the environment was correctly set up, I should be able to reach either this web server or this VM here, and I'm not able to reach any one of those. So this is the outside device I'm using to peer with. Okay, so show SPF. Show IP route OSPF. Yeah. Show what was in these notes? Okay. So I'm taking a look at the OSPF routes. I'm seeing the two SBIs I define on ACI, and those are directly connected. And I'm getting the 1.1.1.1, 1.1.1.2 that has been defined, so I'm getting those as OSPF, but I'm not getting the 192.168 101 network. Okay. If we go back to ACI, what we just did was setting up config for the L3 out, right? And I defined the network, which was the external endpoint group, but there's no place I've defined what I want to advertise. We said we had two choices, either creating a route map or associating the L3 out to the bridge domain. So we'll first take a look at doing this. Go back to policy, L3 configurations, associated L3 outs, and we're going to choose this L3 out. Okay. Once we do that, we should see that I start getting the route here. So I'm getting the route, and that route is being advertised out of the two nodes. Okay. So let's try the verification from this jump machine. Now we're going to try to see if we can get to that server inside of ACI. I'm still not able to get to it. However, ACI is getting the routes. So ACI is getting routes through OSPF. However, I'm still not able to get to this jump machine or back. So the part we're missing, as it was mentioned, was we need to define contracts on the L3 out. So the L3 out is going to follow the same logic as basically as any endpoint group. It has the logic of provided contracts and consumed contract, and you have contract interfaces and taboos and inherited contracts. Taboos are basically deny contracts, and the contract interface is for leaking between BRFs. Okay. So if I want to be able to have this work, I need to allow connectivity. So I'm going to say that I'm going to provide contract here. And I'm going to have to allow the contract. Actually, I'll do it the other way around. So he's going to provide the contract. And the L3 out is going to consume the contract. So now when I do this, I should be able to get to that server now. So when you're working with L3 outs, you need to remember that regardless of if you see routes from a networking perspective, connectivity is not going to be established until you have a contract, because the external endpoint groups still need to have the logic of using contracts and consume and provided contracts. Okay. So with this, we've gone through the basic settings for the L3 out. Let me bring up the basic settings for the L3 out, how to establish the routing, how to associate the L3 out to the bridge domain to advertise routes, and how we work with the contracts. Okay. Are there any questions up to this point? No, we're good. L3 outs is probably one of the longest topics in ACI. There's multiple options and there's multiple things you can be doing. So I know we're going pretty quick, but we still have a lot of topics to cover. So if there's no questions, we'll keep going. So what happens if I don't want to use bridge domain to advertise routes, right? So if I come here and I erase this, and I'm not, I'm going to see that this communication is going to break because I'm not advertising the route anymore, right? So how do we reestablish that? So we can create a route map. So this is going to be an export. Because basically what I'm doing is I want to advertise routes out of ACI. This test is going to be permit. The match rule is going to be the actual prefix. So it's going to be web. I'm going to say 192.168.101.0/24. Okay. You could create a set rule if you need to change any of the attributes. My example, I don't really need to change anything. So we create the rule. It's an export. We have the matching. So we created the route map. If we take a look again here, now this should be working again. Okay. So you have two ways to do something that's fairly similar. So what would be the difference of using bridge domains to advertise routes against using route maps? Well, if you want to use ACI for transit routing, then you will need to use a route map. There's no other way of doing the transit routing than using a route map, because basically you're not going to have a BD defined inside of ACI that you can use to bind to the L3 out. Okay? So in the case of those of you that are using ACI as transit, then you will need to define route maps. If you're not using ACI as transit, you could choose the two options we showed. So which one would you prefer? It comes a bit to personal preference again. I like doing it inside of the bridge domain because from an operational perspective, it's easy to achieve, right? What I mean by easy to achieve is I might have someone that's working on ACI that it's a junior level person that it's not as familiar with routing, and he might be doing operational tasks like creating endpoint groups and creating bridge domains. And from an operational perspective, if someone calls you and says, "Hey, I need to create a new application, I need to deploy a new web server. Can you create the endpoint group and the bridge domain?" You can create the endpoint group and the bridge domains as we saw before. And then the only thing they need to know is they need to come here, they need to click on the L3 out, and that's everything they need to know. If they click that, the L3 out is going to be working. The routes are going to be advertised, things are going to be working, right? So it's slightly simpler because you don't need to create a route map or go through any steps. It's just you come here, you click from the drop-down menu, and you choose the L3 out. The drawback of doing it this way is that you don't have as much control. Basically, everything you have defined as a subnet here, as long as there's an endpoint group connected, that is going to be advertised on the L3 out. So if I had 20 subnets inside of the bridge domain, I would be advertising 20 subnets as long as they're marked as advertised externally. If I wanted to summarize those routes, I can't do it with the options I have here, right? I can only bind the bridge domain to the L3 out. Whereas if I'm using a route map, I can use the route map for summarization. So it really comes to, to personal preference for those of you that have more of a network-centric deployment where you have one subnet per bridge domain. It might be easier to just tie the bridge domain to the L3 out, especially if you're going to be having multiple L3 outs, because the steps are just easier to repeat from an operational perspective. The end result, as you saw, it's going to be exactly the same. You're going to have an OSPF route that's being advertised to the outside world. The other thing is, if you need to change the metrics or change any of the attributes, you would use a route map for that. On the bridge domain, you have some much limited choices on what you can do and how you do that advertisement. Okay, so that finishes the part on the L3 out properly. So now we understand what an L3 out is. Let's take a look at the options I define for the network. I'm sorry. So we'll take this first option, external subnet for the external endpoint. This is the default setting. Most of the time, you're going to see that this is clicked. So what would happen if I uncheck that selection? Okay. So from a routing perspective, I'm going to see that nothing seems to be changed. Okay. I'm still getting the routes. However, if I try to reach the server, you're going to see that I'm not able to get to it. The reason for that is what that option is telling me. It's saying that whatever prefix I define as the subnet, I want to match that prefix for the external endpoint group, which basically means I'm going to say that anything that's coming from that prefix range is going to be part of an external endpoint group that ACI is going to create. So a TCAM entry is going to be created, and you're going to get the contract of whatever contracts you have defined here on the contracts, right? So it means that if I deselect that option, regardless of the contract being there, ACI is not going to create an external endpoint group for the prefix 0000. Okay. So that's the first option to go through. Sorry about that. That's the first option to go through. Okay. Then we have export route control subnet. Basically, if I want to do transit routing and advertise the subnet. Okay. Import route control subnet. is not going to be available to you here because you are not using BGP. So this option is specifically to BGP to control what you can accept. And then you have shared route control subnet and shared security import subnet. So let's take a look at why we would need to set up those options. Okay? So let's say I have my physical topology that looks something like this. I have the spines and the leaves, and I'm going to have a router here. I can say it's connected this way. Okay, and this takes me to the outside. I don't care if this is the intranet or campus or whatever it is. So we have that physical topology that looks something like this. Now, from a logical perspective, I'm going to say that obviously I have multiple tenants in ACI, and I can say that I have a production tenant. I can say that I have test, and I can say I have compliance. Okay, so I have that physical topology, but from a logical perspective, I have 3 tenants defined inside of ACI. Okay? Those 3 tenants, they are all going to need some sort of outside access, right? And in my physical topology, I only have one device that's providing that access, which is this device. So one option would be for me to set up an L3 out for prod, a different L3 out for test, and a different L3 out for compliance. So for me to be able to provide external access to the servers that are going to be connected to each one of those tenants, I would need to go through the steps we just showed, and I would need to create an L3 out for each one of them. I need to give them IP addresses. I need to set them up on this outside device as well. I have 3 different sessions going on, which can be a problem. And you might also, depending on the physical topology and the number of leaves and the routing protocol you have, you might run into some other limitations, especially around running EIGRP. So this is one option, but it doesn't seem very efficient, and I'm mentioning that I can run into some issues. So what is the other option? The other option is, instead of creating an L3 out for each one of them, I'm going to create a different tenant, right? And I'm going to say that this is the shared tenant. And I'm going to say that I'm going to create an L3 out between the shared and the outside device. And then what I can do is I can allow within ACI to each one of these different tenants consume the L3 out that's set up. Okay? That's called a shared L3 out, where you're setting up an L3 out in one tenant, and then you're allowing multiple other tenants to consume that L3 out. Okay? There's a couple of options on how to create the shared L3 out. the legacy option and the first option that was supported was creating the shared L3 out on the common tenant. So when you bring up the ACI Fabric, as we mentioned on the previous sessions, there's a tenant that gets created by default that's called the common tenant. Okay? That common tenant that gets created by default has a very specific and unique characteristic that is not present on any other tenant, which is that anything that you create on that tenant can be seen and can be used in other tenants. What I mean by that is, for example, when I was setting the bridge domain, right? If I take a look at the BRFs that are present, I see the BRF that I created, and I see the BRF that are created on the common tenant. If I take a look, I have multiple BRFs created on my ACI environment. There's multiple BRFs. But the only BRFs that are seen that are not from this tenant are the ones that are created in common, right? So if I were to come to common and create the test BRF, for example, sorry about that. So if I were to come and create the test BRF in common, now I would see the test BRF that's able to be used on the specific tenants, right? So when I come to the drop-down menu, I would now see the test. This is only true for the common tenant. All the other BRFs that are set up on different tenants would not be this way. And this is the same for contracts that get created. This is the same for filters. This is the same for bridge domains, right? So anything that is created in common can be seen on any other tenant. So one option for you is to set up the L3 out in common and then have other tenants consume it. That was changed, I think it released 1.2 or might have been 2.0, that you can create an L3 out and be a shared L3 out in other tenants, right? So instead of creating it in common, and I can create a specific tenant with the purpose, so shared L3 out. So I can create a tenant with the sole purpose of being where I create the L3 out and using it for shared. The process of creating the L3 out on common tenant or on any other tenant is almost the same. So it's very similar. The only difference is if you do it in common, you're just going to use the regular contracts that you create. If you create it on this shared L3 out tenant, you will have one extra step to perform, which is export the contract you create in this tenant to a tenant where you have the servers. Okay, so I'll create it on the shared L3 out tenant just to show you that extra step. But all the things we're doing could be done on the common tenant as well. Okay, so what we're going to do is we're going to come here. Then we're going to erase the L3 out. So we're going to go through a process of creating the L3 out on the shared L3 out tenant. We'll go to networking again, turn routed networks. You're going to see that the first part of the config is going to be exactly the same. Shared SPF, out, SPF, RAD1, so Stawi, BRF. So I'm going to create a specific BRF for this. Yeah. Yeah. BRF. Okay. We're going to choose external routed domain as we had before. BF node. One. Good. Node 2. 1.1.1.2. And we're going to create the OSPF interface profiles. So OSPF interfaces. CIs again. Choose the node. /45, 61, 192, 168, 201.2/30. Set up the MTU. Here ahead and do the second part. 5 as well. 81. 168.201.6/30. And that was 1500. Okay, so this looks good. Looks good. I'm going to create the external endpoint group. So external endpoint group. Okay. And I'm going to do a 00 prefix again. Here we're going to go through a couple of more examples so we really understand how this works. And for now, I'm just going to leave the default setting of external subnet for the external endpoint group. Okay. Up. Okay. BRF. So if we do show IP OSPF neighbors, BRF. Okay. We see that it's coming up. We connect to the other one. We'll do show IP. So the neighbors are coming up, which is good. Let's check the routes I'm getting. Show IP route. Show IP, OSPF, BRF. Okay, so I'm getting all the OSPF routes. So that is good. But what we said we wanted to do was to do leaking, right? So what I'm trying to achieve is to have tenant group 1 be the one that can consume the L3 outs. So take a look at the tenants. One. This is the guy that should be getting the routes. So we'll take a look here. So we'll do show IP route BRF 1. This guy is not getting any of those routes. Okay. So what we have missing here is we need to define how we do the leaking. The only thing I did so far was I created the notion of the L3 out, and that notion is on a different tenant. But up to this point, I haven't done anything that's different. Okay. So how do I do the leaking, the actual leaking? So for me to be able to do the leaking, I'm going to use contracts. Contracts is how you do the BRF leaking inside of ACI. So I'm going to create a contract. And I'll say this is the shared L3 out contract. And I'm going to change the scope. And I'm going to set this to a global scope. The reason I'm setting up this up as a global scope is because this is going to be created and I need to export this contract to a different tenant. So I'm going to set it up as global. I'm going to create a subject, and I'm just going to use an any subject. So basically, I'm not trying to do any filtering for this. So we'll do any. We'll quickly create an any filter. So I'll just any here, and I'll leave it as unspecified to create the contract. So okay. So I created the contract, and that contract was created as a global contract. Outside of that, it's a standard contract. The next step is I'm going to right-click standard contracts, and I'm going to choose to export a contract. I'm going to give it a name, shared L3 out. I'm going to choose a shared L3 out contract, and I'm going to say that I want to export this to the group 1 tenant. Okay. So if I go to the group 1 tenant, I take a look at the contract, imported contracts. I have this contract here. What I'm going to do now is I'm going to go to the L3 out again. On the L3 out, I'm going to go to the policy. You can go to a network here, or you can just go to a network here. Contracts. And I'm going to say that the L3 out is going to provide the contract. So shared L3 out tenant. So I'm going to apply that contract as provided here. And then I'm going to go to the endpoint group I was using. In this case, it's the web server endpoint group. Then I'm going to apply the contract, but instead of using it as just a consume contract, I'm going to use it as a consume contract interface. Right? And I'm going to say that the consume contract interface is the shared L3 out. And the next step I need to go through is when I take a look at the subnets, this subnet was marked as advertised externally, which means the subnet can be advertised through an L3 out. But now I'm not only advertising the subnet, but the subnet needs to be shared between BRFs because I'm working on the group 1 BRF here, and the L3 out is on the shared L3 out tenant, so a different BRF. I'm going to set this up here. Okay. So I'll take a look at what I'm seeing on this device from the outside first. So I see I'm getting the route. Route is being advertised out, so that is good. However, if I take a look at the leaking, I'm still not getting the routes. Okay. So why is it not working? I'm obviously the leaking or some sort of leaking is taking place because I'm able to advertise the route outside from ACI. The outside router is getting my routes, but I am not being able to get any routes in. Okay. So I want to take a closer look to what routes I'm learning. So show a POSPF route, BRF. So I'm learning all these different routes. So I'm going to take this route, for example. Okay. So I'm going to go back to the L3 out. Okay. I'm going to go to my network statement. I'm going to go to a subnet. And what I'm going to do is I'm going to erase this subnet I have here. Because there seems to be something wrong, right? So we'll erase this one. And I'm going to create a new subnet. But this time I'm going to use the 172.16. So 172.16.151.0/24. Still leave that same default setting. Oh. All right, so let's see now. I'm still not getting it. So now we're going to understand these options we have here. So we have shared route control subnet and shared security import subnet. So let's take a look at the first one, shared route control subnet. Shared route control subnet basically means that I can advertise or I can consume this route on a different L3 out. I can advertise to a different L3 out. So I'm going to select the option for shared route control subnet. And now I should start seeing that route populate here. Take a second. There you go. So the moment I select the option for shared route control subnet, I can start propagating routes. Okay. So let's take a look if I can reach the web server. Okay. So I'm not able to reach the web server yet. So the next option to understand is this option for shared security import subnet. So the shared security import subnet is basically the same as external subnet for the external endpoint group, but for shared routes, so for shared BRFs. So basically what I'm saying is I want to take this prefix, and when this prefix is getting imported to the group 1 BRF, I want to use this to define the external endpoint group. And now I'm able to get to that server, right? So those are what those two options mean. One is to control what is actually getting advertised, and one is to control if that is going to be part of the external endpoint group. So I'm cheating here because I have a different option that I had before. I wanted to use a 000 prefix. And the reason for that is I might not know who's going to be talking to me to the outside, right? I might have internet access, so I don't know what the source is going to be. So I'm going to erase this. Okay. And I'm going to go through the process of doing the 000/0. Right? And I'm going to select just the same options. I'm going to do shared route control subnet and shared security import subnet. So I want to take a look at what happens now. Yeah, so I'm going to give it a minute. I'm still not getting the route. Right? So this is where this aggregate shared route option comes into play. So I'm going to select this. Give it a minute. There you go. Okay. So why am I getting the routes now with that shared route control subnet option? And why do we see a different behavior than when I have the specific prefix? Okay. The reason we have these different behaviors is if you aggregate share routes, basically you are telling ACI to use this 000 to match the routes that are being advertised on OSPF and advertise those into the tenant, right? The destination tenant. The reason the 172.16.151.0/24 was working was I was explicitly defining that /24, and that /24 was the exact match that I was getting advertised on in OSPF. So I had that as a /24 route in OSPF. That's why without the aggregate shared option, that was being propagated to the destination tenant. When I'm using the 000 subnet, because I'm not actually getting a default route advertised, ACI is not propagating the routes. So what I need to tell ACI is use this prefix to catch all the subnets that you're being advertised that match this prefix and advertise into ACI, right? In this case that I'm using the 000, all the OSPF routes are getting advertised in, right? I'm getting the 11, the 12, the 10.1, and the 172, right? If I, for example, were to change this, and say I'm going to use the 172.16.0.0/16 now, for example, and I'm going to give it a couple of seconds to propagate the routes so we can do a side-by-side comparison. Good now. Now only the 172 is being propagated because the 11, the 12, and the 10.1 OSPF routes are not being matched by that network statement and the aggregate shared. Right? So if you have specific statements here, you don't really need to aggregate. If this is going to be something like an internet access and you're going to be using that 000 prefix, then you do need to use that aggregate shared option. If not, the routes are not going to be propagated. And the other thing that's important to keep in mind is shared security import subnet works the same way as external subnet for the external endpoint group, which basically means this option controls the actual contracts getting applied. So if you deselect that option, all the routes are still going to be there, but the actual access to a server is not going to work because ACI is getting routes, but it's not instantiated the contract matching this subnet to actually apply the contract. When I select that option, that's when this is going to kick in and it's going to start working. Let me open one so you can see it loading. So that's one thing to keep in mind. The other thing is when you're working with shared L3 outs, there's no need to associate the bridge domain to the L3 out. As you can see here, I'm not associating the L3 out to the bridge domain, but the routes are still being advertised. Right? The reason this works this way is because you're using the contracts for the VRF leaking and you're explicitly applying the contract to an endpoint group, that contract is what's controlling what routes are being advertised, right? How the leaking works. So that's why even if you don't have the associated L3 out here, you're still getting the routes advertised. And then the last thing I said is if we were doing this config in the common tenant, the process would be the same. The only difference is you would just create the contract here, apply as provided on the L3 out and as consumed on the tenant of destination, but you don't need to export it or use it as a consumed contract interface. But the logic would still be the same. Right? Okay. So that was a pretty long, non-stop explanation. Any questions or anything you want to go over again on this topic?